In our previous video, we looked at making the schematic for the Make Monobox, an LM386 amplifier chip. Here I am going back, I'm tidying up the schematic so that I've got everything nice and easy to read, all of the values arranged so that nothing's over top of the components, and we can go ahead and use the print command to print out a PDF of that. All right, we also put our components onto the circuit board, so now I'm coming over here to arrange them. Remember that the air wires in here, the yellow lines, are just an indication of the nets that you're going to have to eventually route. You don't actually have to follow the lines laid out by the air wires. This is just a guide, nothing to panic about right now. If they cross each other a little bit, that's a problem that you're going to have to solve later on. But you can save yourself a lot of hassle by trying a few different arrangements of your components before you start routing. So after a little bit of practice, you'll start to get a sense for where things sit and how they go together. And if you get things arranged really nicely in here, you'll find that you can draw nice straight lines when it comes time to do your routing. And here we go. We've just about got everything in place right now. And it's time to start routing. So there we go. Start with some of the easy ones first. You can go underneath the integrated circuit, just like you can go underneath any component in there. And here we go. Ooh, double back right there. I don't really like that. Clean that up and make it a nice T-joint right in there. Okay, where are we now? Using the Alt key, we can get fine control over our spacing. So Alt lets you use the fine grid. If you don't have that turned on, you're just using the coarse grid. And that lets us tuck a couple of lines underneath that 8-pin DIP chip. There we go, no doubling back on that one. And nice straight lines underneath there. Oops, where's this one going to go? Around the outside. Very nice. And let's go ahead, quick design rule check in there. It's not giving me any problems. Let's shrink the board down a little bit so that we're making this as small as we can. You don't want to go so small that it's impossible to do things, but you do like to tidy it up. Now we can come in here and chamfer some of these corners. Miter is actually the term that they use on here. The electrons really don't care that much on a circuit like this, but well, less distance for them to travel, I guess, and maybe a little bit easier to etch without some of the 90-degree corners on there. Now here I am doubling up on the ground lines, and I'm going to go along and I'm going to increase the width of the ground traces right in here. I'm going to do that for the power traces as well. And when you get a chance to do that, you've got space on the board that allows you to do that. That's going to help you out with your power delivery. Your greatest amount of current in the circuit is going to be flowing through your power and your ground lines. So if you can make them a little bit wider, there's just more copper on there to help carry that current, and there's going to be less resistance in the line, and you're going to get the power out to your components with a little less disruption in the signal. When you're dealing with analog circuits, dealing with noise really is a big deal. So being able to have a little bit more copper right there does kind of help out. Power distribution in a circuit really is a significant thing. Okay, so here we go. Time to put some mounting holes in here. For a small board like this, 2 mounting holes will probably do the trick. And let's see, let's put our name on here and mark up what the project is, what it does. If you've got space to put in what chip you're using, that's a nice feature too, because you could be looking at this board in a year or two and say, oh, I think I remember this circuit. What chip is supposed to go right in there? All right, let's just tidy up some of these component names and numbers. They're going to be on the top layer, of course, so it's okay if they go over top of the existing components. And there we go. That's starting to look reasonably good. Oh, 1 or 2 more to tidy up. It doesn't have to be quite as neat and tidy as the schematic. The schematic, again, is meant to be read and explain the circuit, whereas this is a practical document that's meant to make the circuit. Went to print it, but oops, forgot to turn off all the top layers. Come back into my layers command and get just the pads and the bottom copper turned on. There we go. Turn everything back on, save it all up, and we are done.